Hello everyone. This is Dr. Vijay Lakshmi, Associate Professor, ECE Department, Vardhaman College of Engineering. Today, I'm going to discuss elements of communication system and need for modulation in analog communications course. So, coming to the communication system, we want to transmit or exchange information between one point to the another point, or one to many points, or in between many points. So, information must be transmitted between all these points can be called as a communication process. Communication process is defined as a process of exchanging information between one point to the many points. So, to do this process, we required something like an information source. From this, the information will be generated, and that information will be applied to the transmitter. So, that signal which we are not transmitting here directly over the channel. So, the information bearing signal must be converted into a suitable form so that it can be transmitted over the channel. So, within this channel, noise will get added to this and the signal will get distorted. And the distorted signal and the signal which we want to transmit to the receiver will be received at the receiver side. The process which is taking place at the transmitter side must be taken in a reverse in the receiver side. And the destination point, we must get the same signal as what the signal was generated at the information source. So, coming to this information source may generate many type of signals, something like a voice, a video, text, or data, which we would like to transmit to a longer distance. So, that will be the information source. Coming to the transmitter. So, this is something like an electronic circuit which is converting that information bearing signal into a suitable form so that it can be transmitted over the medium. And the communication channel. This is a channel or media which connects the transmitter and the receiver. And this channel will be divided into something like a wireless channel or a wide channel. If it is a wide, we may use a coaxial cable or optical fiber or anything. Or if it is a wireless, a free space will be the wireless channel. So the next one will be the receiver. The reverse process is taking place at the receiver side compared to the transmitter side. And the noise, this is an undesirable energy which is getting added to the signal and which distorts the information bearing signal in the channel. So we need to consider this noise into picture and we need to develop an efficient communication system. So the main process which is taking place in the transmitter side will be the modulation process. So what is the requirement of the modulation process? So this modulation process basically converting information bearing signal into a suitable form which can be transmitted over the media. So the requirement, what is the necessity of the modulation? The first necessity here is the size of the antenna. If you want to radiate the signal through the channel, then automatically we need to consider the size of the antenna. So size of the antenna will be directly proportional to the wavelength of the signal. Size of the antenna is directly proportional to the wavelength of the signal, where this wavelength of the signal lambda will be equals to c divided by f, where c is the velocity of light, which is equal to 3 into 10 to the power of 8 meters per second. 3 into 10 to the power of 8 meters per second, and divided by frequency. If we will consider the voice signal, so voice signal ranging from 0.3k to 3.4 kilohertz. If we will consider as a frequency equal to 3 kilohertz, then lambda equal to c by f, that 3k will be substituting here, which is equal to 3 into 10 to the power of 3, which will be equal to 10 to the power of 5 meters. So wavelength is directly proportional to the size of the antenna. Then if it is directly, then the size of the antenna will be 10 to the power of 5 meters. Antenna is required. If we'll translate this 3 kilohertz signal to a 3 megahertz signal, frequency translation, if we'll do here, or frequency shifting, if we'll doing here, 3k is shifted to 3 megahertz, then the wavelength of the signal will be equals to same, say, divided by f, which will be equals to 3 into 10 to the power of 8 divided by 10 to the power of 6, which is equal to 100 meters. So 100 meters of antenna is required if we'll transmit a 3 megahertz signal. So if we translate a 3 kilohertz signal to a 3 megahertz, size of the antenna is getting reduced. So this is one basic requirement to go for the modulation process. Coming to the second one, frequency translation. So we need to transmit a signal from various sources by mixing over the channel. So just because of that, so frequency translation is the second reason. Let us consider two information sources here. Source 1, source 2. So I'll be considering here M1 of t and here it is M2 of t, which are ranging with the same frequency ranges from minus 3 kilohertz to plus 3 kilohertz. This is M1 of f and this will be M2 of f from minus 3k to plus 3k. If we will transmit these two signals without any modulation process, these two signals will get mixed, and at the receiver side, we will not be able to separate those two signals. Instead of that, if we'll translate this M1 of f to a carrier frequency of FC1 will be equal to 10 megahertz by using a modulation process. Then the same frequency signal, it will be shifted to 10 megahertz. And this M2 of f is frequency translated to the FC2, which will be equal to 20 megahertz. So this is the second signal, which is translated to 20 megahertz. Now, if these two signals are combined and transmitted over a channel, will never get mixed. And easily we can separate these two signals by using a suitable bandpass filter. So, if we'll do the frequency translation, easily we can separate these two signals. The third reason here is this multiplexing. So multiplexing means transmitting many signals over a single channel. So just because of the frequency translation is possible, we can transmit many signals over a channel and easily we can able to separate those two signals. Coming to the fourth one is the reduction of noise. Noise effect will be reduced on the signal if we'll use the modulation process. So like in FM and PCM systems, the noise effect will be very less, and which improves the quality of reception if we'll go for a modulation process. Right. So without the modulation, if we'll transmit a signal, it will be called as a baseband transmission. So putting the message signal as it is on the channel will be called as a baseband transmission. But it is not suitable for a voice signals. A voice signals will get, the strength of the signal will get decreased as the distance will increase. So, but this baseband transmission is suitable for a LAN applications. Coming to the limitations of baseband transmission, there are certain limitations. So something like it may not travel to a longer distance. And the limitations and resources required for communication system. The limitations in the communication systems are, two basic limitations are there. They are something like our noise and a distortion. So, and the resources are power and bandwidth. We must use this power and bandwidth very effectively in the communication system. Coming to the limitations, noise and distortion, we cannot do anything on that. But we need to reduce the effect of that on the communication system. So, for a better transmission, we need to use a modulation process in the transmitter side. And the message signal as it is, if we'll transmit, it is called as a baseband transmission. But the message signal is called as a baseband signal or a message signal or modulating signal. And to transmit this message signal over a longer distance, we are considering here a high frequency signal, which is called as a carrier signal. And after the modulation, the signal will be called as a modulated signal. And this baseband signal, here it is represented with this sinusoidal signal, which is applied to the modulator, which results in a bandpass nature of a signal, where the one characteristics of the carrier signal is changed here. And the demodulation process, which is taking place at the receiver side, reverts to the modulation. And in turn, we need to recover our original message at the receiver side. So, the terminology in the communication system that we need to see here. So, coming to the terminology, the information coming from the information source, we'll be calling it as a message signal M of t, or it can be baseband signal, information bearing signal, will be the message signal m of t, and coming to the carrier signal, it will be always represented as something like c of t, which is a high frequency signal. This will be a high frequency, and this message signal is a low frequency. And after the modulation process, we'll be calling it as a modulated signal. And the reverse is taking place at the receiver side. The input to the receiver will be the modulated signal, and the output of the receiver will be a demodulated signal, which must be proportional to our original signal m of t. And coming to the high frequency carrier signal, that will be used within this analog communications and also in digital communications to transmit the information to a longer distance. We are using a high frequency carrier signal AC cos 2 pi FCT. There is a reason behind this why we are using only this AC cos 2 pi FCT. The reason here is we can use the frequency shifting property. The basic requirement which we have seen here, by using the modulation, we want to translate a low frequency signal to a high frequency signal. So shifting has to be taken place. That can be done by easily by using this cos signal. So if I'll express this cos signal in terms of a complex exponentials, so I'll be expressing cos 2 pi FCT in terms of complex exponentials e power j 2 pi FCT plus e power minus j 2 pi FCT divided by 2. So if this complex exponential is multiplied with an x of t signal, which is the information bearing signal, so it is x of t which we are representing e to the power of j 2 pi FCT m of t. In place of x of t, I'll be using here m of t. E to the power of j 2 pi FCT multiplied by m of t. If you'll apply the Fourier transform to this, so we'll be getting m of f minus fc. So shifting, this is called as frequency shifting property of Fourier transform. Shifting the lower frequency to a higher frequency of fc will be done very easily if you will use this complex exponential signals. And these complex exponential signals are present in cos and also sine. So we are always prefer to use this cos only because it is plus and divided by 2 we have. If it is sine, we'll be getting here a minus, and here we'll be getting a j, which is not so easy to handle this minus and j. So instead of that, we'll be always using carrier c of t as this high frequency signal, which is equal to AC cos 2 pi FCT. And this carrier is having certain parameters or characteristics. They are, one is the amplitude, second one will be the angle. So this is angle, and this will be the amplitude. So if the amplitude of the carrier signal is changed in accordance with the message signal, it results in something like an modulation, amplitude modulation. And this angle can also be changed in accordance with the message signal, which results in angle modulation. And this angle is further divided into two more parameters. One is carrier frequency, another one will be the carrier phase. So we can keep our message either in the frequency or in the phase or in the amplitude. So based on that, these modulation schemes are divided into some certain categories. So in analog communications, we have here the two wings. So that will be, one is the continuous wave modulation, another one is the pulse modulation. In continuous wave modulation, the carrier signal C of t will be equals to a high frequency signal AC cos 2 pi FCT. And whereas in pulse modulation, we are not using this AC cos 2 pi FCT, we will be using there a train of pulses as a carrier. And this carrier AC cos 2 pi FCT is having the parameters, something like we have discussed, amplitude, frequency and phase. Based on that, it is divided into amplitude modulation, frequency modulation and phase modulation. Further, this amplitude modulation is classified into AM, DSBSC and SSBSC, VSBSC based on the resources, how they are utilized. So based on that only, it is classified into AM, DSBSC, SSB and VSB. And coming to the pulse modulation, even the train of pulses is also containing the certain parameters or characteristics. They are amplitude, width and position. If the amplitude of the train of the pulses is varied in accordance with the message, it results in pulse amplitude modulation. If the width of the pulses is varied in accordance with the message signal, it results in pulse width modulation. If the position of the pulses is varied in accordance with the message, which results in pulse position modulation. So all these modulation schemes which we need to study in analog communication course. And we can come to one definition of the modulation. So now the definition of the modulation is defined as uh, modulation is a process in which the characteristics of the carrier signal is varied in accordance with the message. That is suitable for either for your continuous wave modulation or for the pulse modulation, right? And in the next session, we will start directly the amplitude modulation. Thank you.